He was wrong. All right, here we go. Chain rule. So chain rule applies to derivatives in terms of when you're looking at functions that have kind of more than one component. All right. So a lot of times, so it's chain rule. What types of things should you be looking for? You should be looking for like some type of quantity to a power. Here we're going to want to use the chain rule possibly. Anytime we have some type of radical, square roots, cube roots, fourth roots, etc., good chance we're going to use a chain rule. Trig functions, sine, cosine, cosecant, cotangent, good chance we're going to use a chain rule. So the chain rule essentially is we're taking the derivative of what we might consider a composite function. Okay? So a lot of times you'll hear us talk about taking the derivative of the outside stuff and taking the derivative of the inside function. Here's why. So if you take, for example, kind of like a quantity to a power, if I'm looking at something like 3x minus 4, and I have that quantity squared. So there's two big things happening here. One is the quantity being squared, and the second part is the stuff inside the parentheses, the 3x minus 4. So kind of pretty much like a composite function. We had a function that was x squared. We had another function that was 3x minus 4. And we took the 3x minus 4 and substituted into the x squared, so like f of g of x. And we came up with this brand new function. So to figure out the derivative of that composite function, it's kind of like a two-pronged assault. So what we're going to happen is, what we're going to do is this. So the derivative with respect to x of a composite function is the derivative of f prime of g of x times g prime of x. So just notice that inside function we have that g of x. We've got to take the derivative of that. And we're going to multiply all that information together. So again, a lot of times you'll hear math teachers, classmates, etc., talk about taking the derivative of the outside part of the function times the derivative of the inside part of the function. So, again, kind of using that same example, if we take a look at the derivative of 3x minus 4 with that quantity being squared. So the parentheses are acting as kind of that composite part, okay? Because I'm going to take the derivative of this power, but the inside portion of 3x minus 4 remains unchanged. So power rule, take the 2, bring it down in front, inside g of x remains unchanged, just like we see here in our setup. Power of 2 goes down to a power of 1, so put the 1 in, don't put the 1 in, your choice. But then we've got to multiply it by the derivative of this inside function, that g of x component. So the derivative of 3x minus 4, just 3. So now at this point we can kind of go ahead and simplify. 2 times 3 would give us 6. 6 times the quantity of 3x minus 4, which then, if we want to distribute, we could. And that would be the arc derivative. When you've got these quantities to a power, those are typically the easier ones in terms of chain rule. Because you just utilize the power rule, take the derivative inside, multiply it all together, and go done. When we get into radicals and trigs, sometimes it gets a little funkier. questions about what I showed you right here? All right, so a couple examples here to get us warmed up. So f of x equals the quantity of x squared plus 2 to the third power. So again, we want to take the derivative of the composite function. So essentially we're focusing in on the power. So take that power, bring it out in front, leave the x squared plus 2 alone. So that's where we get 3 times the quantity of x squared plus 2 power goes down by 1. But then we've got to multiply that by the derivative of our x squared plus 2. Which is how much? Yep, 2x. Exactly. Right? So my 3 and my 2x we can multiply together and find that our derivative here is just 6x times the quantity of x squared plus 2 squared. Questions there? All right. Try this one on your own. Can't get it. So what's the first thing you did? What did you do did, Angie?
3
Okay, so 3 comes out in front. Inside stays the same, 3 becomes a 2. So what's the derivative of our inside part of the function? Yes, Ashton, that's correct. It's 3 minus 4x. Great. So what we can do here, we can reorganize. We could distribute 3 times that 3 minus 4x. And say that g prime of x is 9 minus 12x times the quantity of 3x minus 2x squared squared. Alright. If you want to multiply the whole thing out, by all means, you're more than welcome to. I don't know that there's a real need to do that. Again, as we get further into our discussion with derivatives, we start looking at how we can use derivatives to sketch different curves of functions. Factor format is probably going to be a little better to deal with. Any questions? You okay there, Sarah? Yeah? Okay. All right. So, we'll make things a little more fun, more interesting here. So f of x equals x squared times the square root of 1 minus x squared. What's that?
I was just wondering what happened to number 3.
Skip.
I just want to make sure I did this.
Go make sure you didn't miss out on it.
Yeah.
Due to other things, reasons.
Well, no, I was just finishing writing down this equation. I love it.
Gotcha. You need to go back to number 2?
No, I got number 2. I
Oh,
just
okay.
want to make sure I did this.
Gotcha. You did not miss number 3.
Okay, yeah.
I think number 2 is probably very similar to 1 and 2, so that's an A. Nobody any questions? You're like, oh, okay, we're figuring out power, down, great, leave alone, inside, stuff, go. You know. Alright. More fun. So, 2 different things here. You've got products, but then we also have our radical here. Good times. Okay, lots of fun here. Oh Lord, that was bad. Let's get rid of that. Okay, so product rule is in effect here because we're multiplying 2 separate functions together, the x squared and the root and the radical. So, how do we want to apply that product rule? Alright, so we'll take the derivative of x squared. Great. So we get 2x times the square root of 1 minus x squared. So we get notes. Plus keep the x squared. Derivative of the square root of 1 minus x squared. Oof. How do we start to do that? What should we look to do first?
Put in parentheses and then put the 1/2.
Okay, so let's make sure we kind of change this into 1 minus x squared to the 1/2 power. So then at that point, we can sit there and go, okay, 1/2 times 1 minus x squared to negative 1/2 power. So there's your power rule for the radical. But then we've got to multiply that by what else? The derivative of the inside of our square root. So 1 minus x squared, derivative there should be negative 2x. So there's our product rule, along with some chain rule involved as well with the radical. Now it's just a matter of simplifying. So how do you want to start to simplify this? Thoughts? What's that? Okay, so easy thing here, x squared times negative 2x. Go ahead and do that. So 2x. Do you want to leave this as a square root, or should we change that into a power? Let's change it. All right. 1 minus x squared to 1/2 power minus 2x cubed. Well, we probably multiply that 1/2 in there as well, right? So really we just have x cubed times 1 minus x squared to negative 1/2. All right. So at this point, we've kind of taken care of some of the easy stuff in terms of x squared times that half times that negative 2x, great. We'll come out with that minus x to the 3rd power. We still have a negative exponent. It would be better served if it was a positive exponent. The question is how we want to go about doing it. We've got options. Ainsley.
You could do 2x times 1 minus x squared to the half minus x to the third over radical 1 minus x squared.
Okay, so we could go ahead and move that into a denominator. Great. Is there a way that we kind of combine those two terms? I feel like we had to do that in some of your website stuff. We had to do it in some of our practice problems. The product rule, quotient rule. Yeah, Kevin, we probably should do that. What's that?
I have no idea.
You should find the common denominator.
We should find a common denominator. It'd be great. It'd be fantastic. People would jump for joy everywhere. So what's our common denominator? I'll give you a clue. Yeah, no way. Oh my goodness. Yeah, common denominator. Quantity of 1 minus x squared to the 1/2 power. This guy's gonna email me like, you shouldn't be doing this every day. Well, you just saved me $9,000. So we multiply this whole thing by 1 minus x squared to the 1/2 power.
And then you have to combine like two things and.
No, I can't combine this stuff with that stuff. It's like
I was like,
a
what?
rational exponent. I'm talking about the two terms.
Okay, yeah, there we go.
Boom,
Find the
boom.
common denominator.
Two
You know,
terms.
we got that. So
Come.
we know how to do that.
I hope so.
Yeah, we're experts at
I'm
that.
like the worst teacher ever.
This country is the best.
Oh my goodness. So 1/2, 1/2. We get 2x times 1 minus x squared minus x cubed divided by 1 minus x squared to the 1/2 power.
It's perfect sense.
Right? I know. We should distribute 2x minus 2x cubed minus x cubed. Oh. 2x minus 3x cubed divided by 1 minus x squared. Just getting away. To the 1/2 power.
Seems very simple.
What's that?
It's very simple. Thank you for.
I mean, it couldn't get any easier if we were slicing bread. Well, you ever think about how hard it really is to slice bread because you don't want to squish it, right?
I think
I feel like one of those you read right now.
I mean, like,
I don't know if it works, but I read that.
when I opened up in there, I sliced every single bread. So we can do that day. So
Yeah.
much.
Nice. That's good. Questions here? No? We're
It's
good?
like so well. So it's
Great. Awesome. Oh, I got one of those right there. Don't know what it was. All right. Ooh. So you've got the quantity of 3x minus 1 divided by x squared plus 3, all of that to the third power. We want to figure out the derivative. So based on what you've seen so far. Right?
Yeah, of course.
Excellent. What should we look to do here?
First,
What's that, yeah?
first we're gonna throw the 3 out in front,
Okay.
because you have to take the derivative of the whole and then to change the inside. And then you'll have a squared form,
Okay.
and we multiply that. The derivative of the inside, but we'll have to use quotient.
Alright. So yeah. We still need to take the derivative of this quotient, which means we have to use the quotient rule. So how do we use that quotient rule to help us out? Sure thing, Mark.
So, quotient rule is low d high minus high d low, low squared. So that's gonna be, take the low, so you do x squared plus 3.
Yep.
The derivative of the top is high, which is 3.
3, yeah, I got you.
Minus high d low, so like the high one.
3x minus 1, your numerator, yeah.
And then the derivative of the bottom, which is gonna be 2x.
2x, great. Divided by
Low squared, which is gonna be x squared plus 2 squared.
our denominator squared. Fantastic. Alright. Yep, so we're gonna start distributing here. Let's put some things together. 3x squared plus 9 minus 6x squared plus 2x. So we combine those like terms. Bingo.
We have to like multiply it together if we just do like
What's that?
that. Can we just do it like that, or do we have to like multiply and even out?
So, I mean, we kind of bring things together if we want to. X squared plus 3, x squared plus 3. But we've got this power here. So what would we have to do with our power in order to sit there and try to put things together? Take that power, apply it both to numerator and denominator. So if we did that, we have 3 times 3x minus 1 squared, x squared plus 3 squared. Bottom, we've got the quantity of x squared plus 3 to the 4th power. Exactly. 3 times 3x minus 1 quantity squared times negative 3x squared plus 2x plus 9. So if we want everything in like one big tiny little package there, we can do that.
That was nice.
What was?
Big tiny.
Yeah, a little tiny package.
You more than just math here, buddy.
I've
Good
been trying to
presents.
think of the word oxymoron for 3 days now.
We were talking about chemistry.
Great. All right.
But we don't have to do that.
So again, I think it's kind of depends on your situation. Alright, remember we've been talking about how much supplying we actually need to do. I don't think this is out of the realm of possibilities of things you should be able to do. And we should know that at this point, by the power of the quantity that power applies to everything on the inside, so that would be numerator and denominator, so we can kind of put the denominator all together. But if things got really crazy, then, we'll have that discussion. What's up?
Hi.
How's it going? Oh, that's right, Jan's being somewhere today, right?
Yeah.
Who you got? Where are you guys at?
Excellent.
Oh, that's right, so cool, so fun. You're not here, you're going. All right, any other questions there? Lovely. All right, so we'll get back to chain rule next week. We're gonna quiz on Monday, product rule and quotient rule, go figure vertical motion problems that are under review. If you have questions, you can refer to the solution key that is on Google Classroom, with the exception of problem number 5, but I'll probably update that and rescan it and put it in. Thanks to Grace and her wonderful mathness. All right, good job, Grace. All right, if you need something over the weekend, email me, whatever. Okay? Otherwise, I'll see you guys Monday, quiz day. Probably like 20, 25 points, somewhere in there. So we can study your trip. All right. Good job. Thanks.
I'm just
If I can,
I can put the notes in classroom, yeah. Sorry about my hand.